operations you have and what you're trying to do. If you're trying to break a thermal line up, a lot of times we're started a lot earlier than that.
I owned a house over on Moses Lake several years ago,
Okay.
and they used basically a pump system that pumped the water
Right.
up, and they had large, basically fountains coming out. You know, which you're getting your water basically, you know, moving around, so you're bringing the bottom to the top. Does that work?
Well, it works, I mean, you're taking the cold water from the bucket.
Yeah.
I don't know where the intake for that specific aerator is. I mean, generally, a lot of times those aerators are put in at specific depths, sometimes they're put at the bottom, and so it's hard to say exactly what they were trying to do. But if they're shooting water up in the atmosphere, they're basically circulating and oxygenating in that way. And that's a way a lot of relays do that. The other thing, we talk about oxygen levels. It really, there's a big factor involved when you're taking oxygen out of a sample in a way. Specifically because it depends on when you're taking it. If you're taking an oxygen level during the daylight, when the sun is out, and the algae is photosynthesizing, you know, algae produce oxygen. So you're going to get a high oxygen level. If you take that same sample site and on Lake Lorraine and take it at night, the process is reversed. The algae isn't producing oxygen, it's taking oxygen in and producing CO2. So it's taking oxygen out of the system. So you may have a reading in the daytime of 10 parts per million. You come back at nighttime at 3 o'clock in the morning and find out that oxygen level is only 2 parts per million. This has never been done on Lake Lorraine. All the oxygen levels that have been taken on Lake Lorraine have been done during the day. Next question. One of the, another avenue that Herrera looked at was chemical control. And they did not recommend the use of herbicides unless they were necessary. One of the problems we see with the Herrera report was it didn't really give very many alternatives. They say that the lake is full of weeds, but their alternative for weed control is they wanted manual weed control, which was hiring a bunch of volunteers to go out and handle their weeds, putting bottom screening material down, which is really only ideal for small isolated areas. You can't put bottom screen down on 6 acres at the bottom of the lake. And the other thing they recommended was weed harvesting. Possible, but I think on Lake Lorraine would be very difficult. Number one, access would be really hard. When we were out there 2 months ago, we just launched a truck and a small boat with huge divots in the grass and along the driveway. So when you're bringing in a piece of equipment that's a couple of tons, I imagine not only you're going to have to worry about the, launching the equipment, there's also going to be repair of the grounds after bringing the equipment back out of the way. So we don't really see as harvesting as a really viable alternative on Lake Lorraine. But those were the options that Herrera gave. We didn't feel that they were really strong enough in any way, shape, or form to try and address the problem. The other thing, since the Herrera report came out, during 2003, Herrera noted there was one specific weed species in the lake, and it's called Elodea. Since that time, Elodea is no longer the dominant species in Lake Lorraine. The dominant species is a plant called Potamogeton crispus, which is on the state noxious weed list. And this plant has to be treated very, very early in the season in order to control it. So harvesting it would not control that particular plant species. The plant is called Potamogeton crispus, curly leaf pondweed. That's the simple word for it.
There we go. All right.
The materials they suggested are materials that are available for chemical control are Pentatrol 191, which has been used on the lake in the past, which is now decided. Sodium carbonate peroxide, which is the PAC 27, which was used this year on the lake. There's also material called Aqua and dipart. All these have been used on the lake in the past. Sodium peroxide hydrate is really the more recent material that's been available for hunger control. Okay, so one of the hypotheses, one of the reason behind the Fosroc treatment that was done this year out on the lake was, number one, you were going to bind the phosphorus to the bottom sediments. Now the question we have is that since there was no monitoring of dissolved oxygen levels in the lake, was that really necessary? Was phosphorus actually being released from the bottom sediment? Because there was enough oxygen down in the bottom of the lake, and there would be no phosphorus releasing from the bottom sediments. And the other part was they would remove nutrients from the water column, which is pretty common of both Fosroc and alum, both nutrient and aggregate. We spent a lot of time looking at the Pereira report and the Fosroc report. There's two numbers you want to remember when you leave here tonight. Number one, phosphorus levels. The recommended total phosphorus levels for a lake is to be around 20 parts per billion. Once you exceed 20 parts per billion, you're getting into the range where you're going to have algae problems. The other number you want to look at is soluble reactive phosphorus. Now, soluble reactive phosphorus is the phosphorus that's available to the algae to grow. In that number, you don't want that number to exceed 10 parts per billion. So just remember those numbers, 20 parts per billion, 10 parts per billion. So in 2012, when the Fosroc was put in, prior to the Fosroc treatment, the soluble reactive phosphorus in the lake fodder was 30 parts per billion, 20 parts above what the standard is supposed to be. 30 days later, it was below the standard. 60 days later, it was getting close to the standard, or it was above the standard. And in 90 days, it was almost close to what it was pre-treated. So although you have a decline from the original phosphorus loading in the lake, you still have excess phosphorus in the lake itself. So if I look at this data, I'm looking at it saying, well, 30 days, the phosphorus level is decreasing, but after that, it started to increase. So what was causing the increase? If you bound the phosphorus into the lake bottom sediments, and you removed the phosphorus from the water column, what was causing the increase? And the first implication is Joe's Creek. Now at 120 days, we see a drop in the phosphorus level in the lake. But the 120-day sample was taken in October, which is probably during the start of the rain. And probably a lot of those nutrients are flushed out of the lake. When you go to 2013, when the additional Fosroc was put in, we haven't been able to find any data at all as to what the phosphorus content was in the lake before the 2013 Fosroc treatment. If those levels were above 29, or close to what they were in 2012, it meant that the 2012 Fosroc treatment was just going to be available for that particular year. It wasn't going to be a long, extended 8 or 7 year treatment scenario. So I think if that data was available, it may have determined if that Fosroc treatment should have been performed in 2013 or not. Next slide. So we look at Joe's Creek nutrients. Very simple explanation. If I were to take a distilled glass of water and put it out on my deck in the sun, no nutrients in it, I'm going to go back a week, no algae, 2 weeks, no algae, 3 weeks, no algae. There's no nutrients in the water for the algae to grow. If I were to take that same distilled glass of water, put it out on my deck, at the end of the first week, I go and take some liquid fertilizer and put a drop of it in there. And 5 days later, I put another drop. 5 days later, I put another drop. Eventually, you're going to reach a threshold in that container of a glass of water that's going to go out. That's basically the scenario that we see on Lake Lorraine, is that you have an incredible amount of nutrients flowing in from Joe's Creek, and although at the beginning of the season, the concentrations are low, that concentration builds up, builds up, builds up, and then eventually you have an algae bloom. Now, when you go back to the 2003 Herrera report, there was data available on Joe's Creek. There was data that was supplied by the stream team on Joe's Creek. They sampled 3 stations on Joe's Creek, probably 5 or 6 months out of the year during the summer. And they found the same levels of nutrients, elevated levels, higher than you're seeing here today. So there was a strong indication, even back in 2003, that the problem is associated with Joe's Creek. Next slide. Okay, so what are we planning for 2015? We know that there's incoming nutrients from Joe's Creek. We know that the Foslock treatment did work on a yearly basis. Now, it's hard to say how that program was sold to the association. Was it sold